So let's talk about some more properties of definite integrals. So now we're going to have two functions that we're going to look at. If f and g are integrable on the interval a to b, and supposing that k is a constant, the integral from a to b of k times a function would be k times the integral of f. So you can essentially take scalars, coefficients, and pull them outside of the integral, a definite integral. And then property 2 says if you have a sum or a difference of two functions here, you can split it up into two separate integrals, a to b plus or minus a to b g of x dx. So these are similar properties to the ones that we saw for derivatives, but now they're for definite integrals. And now let's look at an example. Let's evaluate the integral from 1 to 3, negative x squared plus 4x minus 3 dx using the following facts, the following values. The integral from 1 to 3 of x squared is 26 over 3. The integral from 1 to 3 of x is 4. And the integral from 1 to 3 of dx is 2. So we're going to start with our problem of the definite integral we were given. So we're going to start with that one I've underlined. And the first thing we're going to do is we're going to use property 2, and we're going to split up this addition and this subtraction into separate integrals. So the integral from 1 to 3 plus the integral from 1 to 3 plus the integral from 1 to 3 of negative 3 dx. So that was all using property 2. Now let's use property 1 now and pull out some coefficients. Let's pull out a negative 1 out of the first one. Let's pull a 4 out of the second one. And a negative 3 out of the second one. Now these three values here, these three definite integrals, these values were given to me in the problem, right here, up here, here, and here. So I can now plug in for those. So this is negative 26 over 3 plus 4 times, this one was 4, and then a minus 3, and we were told that this one was 2. So in the end, I'm getting negative 26 over 3. 16 minus 6 is 10. If you get a common denominator here of 3, you'll get 4/3. And there's my answer using the properties that we started off with.